And this is a situation where it is helpful to do the piecewise thing where you actually look at the one, because here you can it can help you visualize the functions. I mean, you could actually graph this in Desmos, but you don't need to. It's overkill to try to figure out how to graph this. You can just use the formulas. So the limit as x approaches 1 from the left of h of x, you just have to think about, okay, I'm headed towards x equals 1. So if I'm headed towards x equals 1 from this side, I'm still smaller than 1. So I'm using the formula x squared plus 1. So as x approaches 1, what y value does x squared plus 1 approach? It's like I'm using this formula. So because it's just getting closer and closer to 1, x is getting closer and closer to 1, y is getting closer and closer to whatever the y value from this function was. So I'm on this side, I can use x squared plus 1. So limit as x approaches 1 from the left of x squared plus 1. And that's just, I can get that by plugging in the number, because that's what happens on the graph is you just plug in the number. So this limit would be equal to 2. And on the right-hand side, now I'm dealing with this x minus 1 because I'm a little bit bigger than 1. So I could write out the limit as x approaches 1 from the right of x minus 1. That's the same thing as 1 minus 1, because the behavior is determined by this formula, which is 0. So my answer to part A on that question would be 2. My answer to part B on that question would be 0. What would you say for C? Does not exist. If the two one-sided limits disagree, the limit does not exist.